they came back with a view of the moon as being a place that was completely dry, completely without water, completely without air, and a place that was geologically dead, no geologic activity. But our view of the moon has changed since then. We have had a series of new robot explorers of the moon, and they have come back with a new story of the moon, and we see the moon now very differently. This new understanding of the moon came about because we realized that at the poles of the moon, the sunlight does not shine straight down. Instead, it comes in along the surface. And so if there's a crater at the surface of the moon, sunlight shining over the top of it will not shine down into the bottom. The bottom of that crater will be in shadow. And there are craters at the poles of the moon whose floors have not seen sunlight in more than 1 billion years. And because they are so dark and have been so dark for very, very long, they are very, very cold. And therefore, we started to realize that if water ice was going to form anywhere, that might be the best place to look.
Bueno, chicos, yo les voy a ir haciendo la traducción un poco de lo que va diciendo Brian para que puedan ir entendiendo un poco lo que nos está platicando.
In the 1990s,
Brian, lo que nos está
they sent back
platicando su
information
conferencia
that
es
there
acerca de la
might
luna.
be water ice
Él lo que nos está
at the north
diciendo
and
es que la
south
luna en un
poles of the
principio
moon.
era un lugar que nosotros pensábamos
But
que era muy árido. Era un
It
lugar que
really
pensábamos que
depended
no
on
tenía
how you
ningún
read
tipo
the
de vida,
data.
que no tenía, que era como un
And
pequeño
different
desierto.
people looking at the
Pero en estos
data
momentos ya lo han
came to
estudiado
different
mucho más.
conclusions.
Aquí nos está mostrando las
So we
fotos
needed
de
to
algunos
get a
lugares de
better
la luna que se
understanding.
están estudiando.
And so we
Él
sent
nos va a
2
platicar de
new
unos cráteres
spacecraft.
que hay
The
en la
Lunar
luna.
Reconnaissance
Se encuentran
Orbiter
los lugares más
or
fríos de
LRO,
todo el sistema
and the
solar.
Lunar Crater
¿Por qué? Porque
Observation
son
and
lugares
Sensing
donde nunca les
Satellite
ha dado
or
la luz del sol.
LCROSS. We
Y
sent
son
them
estos
to the
cráteres
moon
que se
to
encuentran
give
ahí.
us a much better
Brian nos está
understanding.
platicando un poco de eso porque se ha descubierto
They
que la
launched
luna tiene
together
muchas
on a
cosas muy
single
importantes
rocket
todavía
in
que le
2009.
podemos descubrir.
So both of
Vamos a
those
escuchar lo que nos
spacecraft
dice y les voy
were at the top of that rocket as it launched from Florida. The idea behind LCROSS was actually simple and very exciting. The LCROSS spacecraft, as it went to the moon, carried along with it the upper stage, the top part of our moon rocket, about 2 tons in mass and moving at 2.5 kilometers per second. So very heavy and very fast. As we approached the moon, our little spacecraft turned around and it let go of that big upper stage of our rocket. And that upper stage of our rocket went flying down into a crater at the south pole of the moon. And it slammed into the ground at 2.5 kilometers per second. And it blasted hundreds of tons of stuff up off the floor of that crater, out of the shadows, into the sunlight, high into the sky of the moon. And then our little spacecraft dove down into that cloud of debris, into that cloud of stuff, and it flew down into it, and it tasted it, it smelled it, it analyzed it, and that's how we discovered water ice on the moon. 4 minutes after that upper stage of our rocket hit, then LCROSS crashed into that crater, the mission was over. 4 very busy, very exciting minutes. Did I mention this was a really fun job? This was cool. So here's a picture taken from the LCROSS spacecraft looking down into the dark shadow inside this crater near the south pole of the moon. And if you look very carefully, you see that little white dot inside the shadow? That is the flash from our rocket hitting the ground.
Aquí nos está
If you look
contando cómo
here in this next picture, again, you can see the crater and you can see the shadow, the permanent shadow in it. And if you look, there's a light area, kind of a gray area that shows up in that shadow. And that is the cloud of stuff rising up out of that crater. That is the cloud of stuff that L-Cross is going to dive down into and measure. Oops. And here is the final picture, the final photograph returned from L-Cross. And if you look very carefully, you can see a brand new crater. That is the crater that was formed when our rocket hit the ground. So what did we discover? Here is the data from L-Cross. This is a graph of the spectrum of color of light along the bottom and brightness going up on the side. And that red line you see is the signature for water. That is essentially the fingerprint of a water molecule. And the little black dots are the actual data coming back from L-Cross. And you'll see wherever we have a dip, wherever we have a low point in that water spectrum, we also see a dip in the data from L-Cross. So that shows us that we discovered water on the moon. Now you'll see that there's some other dips in the L-Cross data. That's because we discovered many other things besides water. Carbon dioxide, carbon monoxide, methane, ammonia, many other things. Now the other spacecraft that rode along with L-Cross was the Lunar Reconnaissance Orbiter, or LRO. And LRO is still in orbit around the moon today. And it is doing a very detailed study of the moon. It has a wonderful camera that gives us very close-up views of the moon. It has a laser altimeter that measures all the ups and downs on the surface of the moon. It can look into those dark permanent shadows. It can measure the radiation on the moon. It can measure the temperature on the moon, and it is able to sniff out where water ice is on the moon. One of the things that it has found is that these permanently shadowed craters at the poles of the moon are really, really cold. As a matter of fact, they are the coldest places that we have yet measured anywhere in the solar system. 248 degrees below zero. Gets only 25 degrees above absolute zero. It is really, really cold there. Even colder than the daytime side of Pluto. So this is a really good place to look for ice. Now, we figured that we would find ice inside these craters at the poles of the moon. But we're also finding that there's ice even in areas where the sun shines near the poles of the moon, just beneath the ground. So just beneath the ground, the sunlight is coming in at such a low angle that it does not do a good job of warming up the soil. And so the soil is very cold, and so just beneath the surface, you can have ice. 3 other spacecraft discovered that there are water molecules even away from the poles. So in the ground, in the dirt of the moon, even as you approach the equator, there's a thin scattering of water molecules in the soil. Where does this water come from? Well, we have a few ideas. One idea is that it could come from comets. Comets have a lot of ice in them. They're like big, dirty snowballs.
No
And we know
sabemos muy
that the
bien,
moon
pero
has
aquí hay
been
algunas
hit
pistas de las que
over
nos
and
está
over again
contando.
by comets over billions of years.
Aquí
And so
tenemos
some of
un
that water we're
cometa
seeing on the
y
moon could
tenemos
come from
una imagen
comets.
del sol y de las ráfagas solares.
Another source could be the sun.
Él nos dice que estas
The
pueden ser
sun
dos
has a
fuentes de las
wind
cuales
coming
pudo
off of it, a
provenir el
solar
agua
wind.
que tenemos ahora en la luna.
Wind of hydrogen
Pudo
atoms.
provenir
And
de
as those
estas ráfagas
hydrogen
que nos
atoms
lanza
come
el sol,
speeding across space at very high
pudo
speeds,
provenir
and they crash
de
into the moon,
cometas.
they can combine with
Estos son los
oxygen
cometas.
atoms in the minerals of the moon. And the hydrogen and oxygen can combine to form water.
De los elementos que nos
But one
llegan
thing
de
that we
esto
were
se puede
certain
formar el agua.
is that the water we were seeing did not come from the moon itself. It came from outside the moon.
Aquí está una de las
That is because we
recetas que
now
nos dice
understand that the
que pudo
moon
venir de un
and Earth
choque.
formed together in a giant collision about 4.5 billion years ago.
Más o menos la luna se
A
formó hace
planet about the size of
4.5
Mars and a planet
billones
about
de
the size
años.
of the Earth
Y esto pudo haber
collided,
pasado en esa etapa.
and some of the
gran
debris from that collision ended up forming a ring around the early Earth. So the Earth had a ring, much as Saturn does today.
Dice
And
que
then the
este impacto
material in
pudo
that
generar
ring
que la
clumped
Tierra también
together and
hubiera
it
tenido
formed
un
the
pequeño
moon.
anillo del cual se formó
But
la
because
luna.
that collision had been so very, very hot, we realized that all the water would have been boiled away. And so that's why the moon would have been absolutely dry. That's what we thought until just a few years ago.
Porque cuando se formó,
And
había
then we
mucho
took a
calor,
look
el
at some
cual
of the
evaporó todo
samples
el
that
agua,
were
por eso
brought
sabemos
back
que
by
tiene
the
que haber
Apollo
venido del
astronauts.
exterior.
And some of those samples were little pieces of glass that had been erupted from a volcano. And inside those little pieces of glass,
En la luna,
there were crystal cases, olivine crystals. And inside those olivine crystals, there was lava from deep down inside the moon. And when we use special tools to go inside these little crystal cases and look at the lava, we saw that that lava had water in it. That was a surprise. We now realize that even inside the moon, there is some water.
Dice que con todo esto ahora podemos asegurar que en la
I
luna
mentioned that
tenemos agua.
on
en el
LRO, it has a very, very, very good camera. And here's an example. LRO is taking a picture here of where the Apollo 14 astronauts landed on the moon.
Aquí nos están
And if you look
mostrando
carefully,
las huellas
on the right-hand side of the
del Apolo
picture,
14. El
no,
Apolo
right-hand
14
side.
fue una nave que fue a
so
la luna.
over,
Hay algunas
yeah,
personas
over
que
there, you
todavía
can
dudan
see
si el hombre
where you
llegó
can
o
see
no
what is
llegó a
the
la luna.
descent stage
Aquí Brian nos
of the
está
lunar
mostrando
module. This is what the
evidencias de que
astronauts
sí llegó.
rode down to the
Porque ahí
surface of the
están.
moon on. On the
Aquí nos está
left-hand
mostrando la
side,
plataforma
you
de
can
donde
see
descendieron los
a little
astronautas
white
cuando
dot
llegaron
with
a
an
la
arrow
luna.
pointing to it. That is some scientific instruments that were left on the surface of the moon by the astronauts.
Estos son instrumentos que dejaron
And
los
if you look
astronautas
very,
allá.
very carefully, you will see some dark lines
Y ven estas
in
líneas negras.
between
¿Qué se imaginan que
the
son?
left-hand and right-hand side.
¿Qué?
Those are the
Huellas,
footprints of the
exactamente. Son las
astronauts.
huellas de los
We can even
astronautas.
see the astronauts' footprints.
Imagínense,
This
si
is a
pudiéramos ir a
very
la
good
luna,
camera.
podríamos visitarla como un museo de aquí.
Now,
Yo les
the
estaría
neat thing
explicando, aquí
is
tenemos las huellas de los
that
astronautas, aquí
you
vemos
can
dónde se
help us
bajaron.
study the moon.
Brian nos
And you
dice
can
que
get these
nosotros
images coming
podemos
from the Lunar
ayudar a la
Reconnaissance Orbiter
exploración de la luna.
and help
Ustedes
us
desde su
better
casa pueden
understand the
ayudarle
moon.
a los investigadores de la NASA a
One of the
explorar la
things that
luna.
we do, there are
Pueden
two
entrar a
programs.
estas
There's Moon
páginas
Mappers and Moon Zoo
Y pueden ver
And
cómo
these can
podemos
allow
ayudar
you
desde nuestra
to
casa a la
actually
NASA.
help us determine how old different
Podemos
areas
ayudar a
are
esto, por
on the
ejemplo,
moon.
a clasificar los cráteres.
Well, you do
No
this
todos
by
los cráteres
counting
en la luna son
craters.
iguales.
So you get a picture
Tienen
from
formas
LRO,
diferentes.
and it turns out really old ground on the moon will have lots of craters on it. But younger terrain, say if you had a lava flow that came in and recovered the ground, then you will have fewer craters. So by counting the number of craters that you see, you can figure out how old the land is that we are looking at. There's another wonderful program called the Lunar Mapping and Modeling Portal, LMMP. And this allows you to explore the moon in very great detail. You can get the latest images and all the data coming from the NASA spacecraft. You can measure the size of features on the moon. You can measure the height and depth of features on the moon. It's very exciting. You can create 3D maps and fly over areas of the moon. And you can even connect to 3D printers and print up landscapes on the moon. We even have a mobile app. So on your smartphone, you can explore the moon from the comfort of, well, wherever you happen to be. One of the things that LRO has shown us, that wonderful camera on LRO has shown us, are these strange curving cliff faces called lobate scarps. And these tell a story of a shrinking moon, of how the moon, when it was young, was hot, but as it cooled, it shrank. And as it shrank, its crust buckled. And that is what we are seeing here, is where the crust has actually cracked and shrunk. And when we first saw this, we thought, oh, this is very interesting. This tells us a great story of the very earliest days of the moon. But when we look very carefully with the camera from LRO, we see something very surprising. We see these cliff faces actually lying on top of craters, which means that these cliff faces cannot be that old. They have to be younger than these craters that we're looking at. And now we're starting to realize that this process of this shrinking moon is still going on today. So when we thought that the moon was geologically dead, this argues against that. Another interesting thing is the idea of moonquakes. You are familiar with earthquakes there in Mexico, but on the moon, it turns out there are moonquakes. And these moonquakes can be very strong. They can get up to 5.5 in magnitude and can last for over 10 minutes. Imagine if you're in a magnitude 5.5 moonquake that's going for more than 10 minutes. We have another pair of spacecraft called GRAIL that were in orbit around the moon, and just as LRO maps the surface of the moon, GRAIL is mapping the interior, is mapping the inside of the moon. And it came back with this gravity map that showed us that the moon's crust is about 34 to 43 kilometers in thickness, which is actually thinner than we had thought, and that the moon's crust is very broken up, very fractured. Now, when we think of geology, one of the things we think of is volcanoes. And yes, the moon does have volcanoes. Here's a picture from LRO, and you can see this is where many of the moon's volcanoes are. But they don't show up very well. I'm not seeing volcanoes here, are you? It doesn't look very clear. That's because the volcanoes here are very, very low. Instead of being tall and sharp, they're wide and low. And if we switch, instead of looking at from the picture, from a camera, if we use the laser altimeter, now we can see the volcanoes showing up here. So these are small volcanoes, and they are very low in height. And this is kind of strange because here on Earth, we have great big, what we call shield volcanoes. And on Mars, we have great big shield volcanoes. On many planets, on Venus, on some of Jupiter's moons, on Io, we see these great big volcanoes. Why do we not have those great big volcanoes on the moon? It turns out we do. If we use that LMMP tool again, and we draw a line across this area of volcanoes, the Marias Hills, we see that beneath them, there is a giant, very low shield volcano that all of these are just sitting on top of. So there are big volcanoes on the moon, it's just they are hard to see. But with a tool like LMMP, we can see it. We can also look inside of it. So again, here's our laser altimeter view of the Marias Hills volcanoes. Also using LMMP, we can look at a gravity map. We can see, this is from the Japanese Kaguya spacecraft, we can see where there's strong gravity in red, and weak gravity in blue, and green is in between. And if we combine those two images, we can see this strong gravity beneath the hills, beneath the little volcanoes of the Marias Hills. That shows us that underground, there's this big plug of unerupted lava. And so we're able to see that now. But one of the things that we realized is that all the volcanoes on the moon are very, very old. Most of the volcanoes erupted between 3.7 and 2.5 billion years ago, a long time ago. A little bit of volcanic activity continued into about 1 billion years ago, but then it all pretty much stopped, or so we thought. LRO is now showing us about 71 small areas on the moon where we see signs of what might be young, fresh volcanic activity. And this is very strange to us because our understanding of the geology of the moon says there shouldn't be volcanoes that have continued. But yet, here we see these areas. So that is another mystery for us to understand. Another pair of spacecraft that is orbiting the moon right now, two spacecraft called Artemis. And they are studying how that wind from the sun interacts with the surface of the moon. And one thing we see is that the wind from the sun blows material off the surface of the moon into a long tail, like a comet tail. And as a matter of fact, that tail is so long that once a month, the Earth actually passes through that tail of comets, of moon stuff. And that may actually be a clue as to the formation of the moon's atmosphere. Now again, back when I was in school, I learned that the moon does not have an atmosphere. But the moon does have an atmosphere. It is very, very thin. It's about the same thickness as what our astronauts experience in the outermost part of the Earth's atmosphere when they do a spacewalk at the International Space Station. But even though the moon's atmosphere is so thin, it glows. The sunlight actually energizes the atmosphere of the moon and causes it to glow. Now, you may have never seen the bright glow of the moon's atmosphere, but that's always because it's right next to the big bright moon. But if you could take the moon and remove it, but somehow leave its atmosphere behind, then in a clear, dark sky, you would be able to look up and just with your eye, see that glow of the moon's atmosphere. Again, it's very, very thin, and it's made of a number of different types of atoms and molecules. We also realize that the moon's atmosphere is dusty. We got our first understanding of this from robot spacecraft that landed on the moon before Apollo. And they saw the glow of sunlight reflecting off the dust in the moon's atmosphere. And we think this dust is kicked up into the sky by meteorites hitting the ground on the moon. Why do we care about any of this? Because this type of atmosphere that the moon has, what we call a surface boundary exosphere, this type of atmosphere is the most common type of atmosphere in our solar system. Mercury has one, our moon has one, some of the moons of the giant planets, some of the asteroids, even Kuiper belt objects, distant frozen worlds out beyond Neptune. This is the most common type of atmosphere in the solar system, but we know very little about it. So we decided to study it with a spacecraft called LADEE, the Lunar Atmosphere and Dust Environment Explorer. And LADEE went into orbit around the moon, and then it dropped down low, and it flew through the moon's atmosphere to study it, to let us know what its structure is, let us know what the atmosphere is made of, and let us know how the atmosphere changes over time. LADEE was about 2 meters tall, and it weighed 330 kilograms. Here you can see a picture of LADEE being built here at NASA Ames Research Center in California. After it was built, it was packed up into this special container and put on a truck, and it drove across the country to Wallops Island, just off the coast of the United States in the Atlantic Ocean. And here LADEE is, arrived at Wallops Island, and we took it to Wallops Island because there we have a launch facility. We have launch pads. And this is where LADEE was going to leave to go to the moon. Here you can see LADEE being joined to the top stage of our moon rocket and the protective covering being placed around it. Now LADEE was taken to the launch pad and put on the very top of the rocket. Here's the rocket, and if you look very closely in the upper left, you can see 2 people standing there. So this gives you an idea of the size of this rocket. And here's the rocket there at beautiful Wallops Island getting ready for launch. This is the day of the launch. Things are getting very exciting at this point. We launched after the sunset, and there it is. There's the launch. It lit up the sky. People all along the east coast of the United States were able to see it. Millions of people saw this rocket as it went shooting into the sky. Here you can see it flying over New York City. It was very exciting. And here, I cannot give this talk without talking about the frog. If you look very carefully here, you will see a frog. It turns out near the launch pad, there was a pond of water. And a frog ended up living in that pond of water. That was a very bad choice by the frog. When this rocket launched, that blast of hot gas from the rocket hit that pond and it sent the frog flying. And this picture made all the newspapers. It was on television. It was everywhere. So this became one of the most famous pictures of the LADEE launch. So LADEE launched from Wallops Island, and then it spent 3 months getting to the moon, going through a series of larger and larger loops until it got far enough out to meet up with the moon. And then it fired its engines and went into orbit around the moon. And for 1 month, it stayed up high, so we could just check out everything, make sure everything was working. And after that, then it fired its engines again, it dropped down low, and started flying through the moon's atmosphere. Here's some pictures from Laddie at the moon. And here is sunrise on the moon as seen by Laddie. So after a 100-day science mission, our instruments were still working well. We still had fuel, and so we asked NASA headquarters, hey, things are still working very well. Can we keep doing this mission? Can we continue it? And they said, sure, go ahead, keep going. So we got to extend our mission all the way until April 18th. And at that point, we finally ran out of fuel, and Laddie circled down and crashed onto the backside of the moon. But what we found was that the moon has many different types of molecules and atoms in its atmosphere, and they all behave differently. They all act like separate atmospheres. And we see one thing, sodium in the atmosphere changes depending on the phase of the moon, whether the moon is full moon or new moon. That's very strange, but it turns out that has to do with how it passes through the Earth's tail of magnetic field. And we also see how the composition changes with meteor showers. So meteor showers, as they hit the moon, can change the composition of the atmosphere. So what's coming up? We're looking ahead to another rover mission called the Resource Prospector. And the idea is this robot rover would go to the pole of the moon, it would drive around, it would drill down and pull up ice beneath the ground, it would make water from the actual soil of the moon, and would drive into one of those very dark, very cold, permanent shadowed craters. So these are some of the new things that we are learning about the moon from our new robot explorers. So thank you very much. If you have any questions, I will be happy to try to answer them.
Thank you, Brian. So we're going to start with the questions. Quiero verificar si en Canadá habrá alguna pregunta o comentario. Sí, los tenemos en pantalla, Canadá. ¿Alguna pregunta o comentario?
No, ninguna. Hasta el momento, ninguna, gracias.
Oh, bueno, entonces les pido agradecer la conferencia a Brian. Voy a pasar a Colegio de Ciencias y Humanidades Oriente. Quiero verificar si CCH Oriente tiene alguna pregunta o comentario.
Sí tenemos una pregunta, un momento.
Correcto.
Di la primera y luego dices.
Bueno, la pregunta sería si la lava de la luna es igual que la que existe aquí en la Tierra.
Bien.
She wants to know lava that's from the moon is the same one as we have here on Earth.
Your microphone is mute.
Yes. The water on the moon is similar to the water that we have here on Earth. But it is mixed with things that you wouldn't want to drink. So when we saw that water from the moon, it had other things in it, like mercury, ammonia. So you wouldn't want to just melt that water and drink it. You would have to purify it first.
But they are asking about lava.
Oh, the lava on the moon. Oh, I'm sorry. Yes, the lava on the moon Very good. So if we take a look at this picture we see on the moon here, you see these dark areas? Those dark areas are basalt. So here on Earth, we have many different types of lava. We have basalt lava, which is the thinner, runnier type of lava. We have andesite, which is thicker. We have dacite, which is even thicker, and rhyolite, which is very, very thick. On the moon, most of the lava that we see is basalt, almost all of it. There are a few areas, though, where we do see some of the thicker lava. But the most common type of lava on Earth is basalt, and the most common type of lava on the moon is basalt. Very good question.
¿Alguna otra pregunta en...?
Yes, we have another question.
Buenas tardes. Mi pregunta es si en los próximos 3 años cree que exista una posibilidad de que haya un viaje a la Luna y qué país cree que lograría hacer esto.
She would like to know in the near 3 years they will be traveling to the moon, and if so, what let's say what part of the country would have that access?
It is a wonderful question. So, in the next few years, we do not have planned to send any people to the moon, but we do have plans to send robot probes to the moon. But other space programs, the Chinese space program, and the Europeans, and now even the Russians are starting to look at sending people back to the moon. And so there are also private companies that are looking to send people to the moon and actually mine the moon for some of its resources. So the big question is, who will be the next to go back to the moon? And we are not sure yet. It is a very exciting time, and we realize that the moon is a very interesting place, a much more interesting place than we had previously thought. And so the only thing I can say for sure is that people will go to the moon, but who will be the next to go? It's a race. We will see.
Sí, gracias SH Oriente. En un momento regresamos para más preguntas. Quiero verificar si en el Colegio Ciudad de México hay alguna pregunta o comentario. Adelante.
Arriba, o sea, habla como hacia la cámara.
So I wanted to ask if the craters on the moon are so cold that the Bose-Einstein condensate would appear in the craters.
I'm sorry, I had a little trouble hearing you.
So I wanted to ask if the craters on the moon are so cold that a Bose-Einstein condensate would form there.
Oh, okay. Are they so cold that we would see a Bose-Einstein condensate forming? No, probably not, because the coldest we have seen is about 25 degrees above absolute zero. So it's not cold enough for Bose-Einstein condensates to form, but if you wanted to work with Bose-Einstein condensates, that might be a really good place to do the experiments, because you don't have to do a whole lot more additional cooling to get down to that very low level. That is an excellent question. That is the first time I have ever received that question. Thank you very much.
Gracias, Colegio Ciudad de México. ¿Alguna otra pregunta o comentario?
No, ninguna, gracias.
Gracias, les pido cerrar su micrófono. Voy a pasar a preparatoria 9. Verificar si en prepa 9 hay alguna pregunta o comentario.
Where is the rocket station of that?
¿Pueden repetir, por favor?
Where is the rocket station of that rockets of you work?
Where do the rockets launch from? Is that what you were asking?
Yes,
Station, the rocket
the
station.
place where you launch your rockets.
Okay. We have several places that we launch our rockets. So LCROSS and LRO launched from Cape Canaveral in Florida. That's where we have our biggest launch facility. We also have another launch facility off the coast of Virginia that is called Wallops Island, and that is our oldest launch facility. And then we are also able to launch rockets from out here in California from a place called Vandenberg Air Force Base. And then we have another launch facility up in Alaska called Kodiak Island. And then there is also a launch facility out in the Pacific, on an island in the Pacific called Kwajalein. So we have several places that we do our launches from.
Gracias, Prepa 9. ¿Alguna otra pregunta o comentario?
Sí, how old are the oldest land in the moon?
Very good question. How old is the oldest? This is a great question, and this goes to why we really want to study the moon. Here on the Earth, we study rocks because rocks can tell us stories of how old, or of the conditions that they formed in. If you become a geologist, you learn to be able to hear the stories that rocks have to tell. They can tell us how they formed, where they formed, when they formed. But because here on Earth we have erosion and we have plate tectonics, we cannot find any rocks that go back to the earliest days of the Earth. All those really old rocks have been destroyed. But again, we know that 4.5 billion years ago, we have the Earth and Moon forming together. And on the Moon, you do not have wind, you do not have rain, and you do not have plate tectonics. So on the Moon, there are rocks that go back to close to 4 billion years old. Very, very, very old rocks that can tell us the stories that we cannot find here on Earth. So interestingly, if you want to learn about the earliest days of the Earth, one of the best places to go is the Moon.
Bien. Voy a verificar si el CIATEG se encuentra enlazado. No los vimos durante las pruebas. Quiero verificar si el CIATEG está enlazado.
Hola, ¿qué tal? Buenos días. Aquí está. Muchas gracias.
Quiero verificar si hay alguna pregunta o comentario.
No, nada más agradecerles el tiempo y muchas gracias.
Gracias, CIATEG. Entonces, no sé si aquí hay preguntas.
Si usan el bicarbonato carbono 14 con la luna.
Hi, Brian. Here at Universum, they are asking if you use the carbono 14, the proofs to measure like the age of the moon.
Ah, so like carbon 14, carbono 14. See, no, we do not use carbon 14 because carbon 14 decays too fast. That is good for measuring things here on Earth that, like animals or ancient human sites that may be thousands of years old. But on the moon, we want to go much further back than what we can measure with carbon-14. Also, carbon-14 works here on Earth because of the carbon in our atmosphere. We have lots of carbon in our atmosphere. And the moon doesn't have that amount of carbon in the atmosphere. The moon's atmosphere is too thin. But we use something very, very similar. We can look at different types of atoms, different isotopes of atoms, and the rate at which they decay. Carbon-14 decays over, thousands of years, but we can look at other atoms that decay at a much lower rate, much slower, and can allow us to measure back further in time. So we use a process very similar to carbon-14 dating here on Earth, but we use different types of atoms. So that is one way we measure the age of things on the moon. But another way, as I mentioned before, is crater counting. So again, take a look at this picture of the moon we have here, and you can see that there is, look at this area here with many, many, many craters. Now look at this area up above with many fewer craters. Which area do you think is younger and which area is older? Well, it turns out those lava flows, where there are very few craters, that's the young part of the moon. Those areas you see down below and to the left where there are many craters, that's a much older area on the moon. So by counting craters, we can get a good idea of how old different parts of the moon are. And again, this is an area where you can help, where you can actually participate and help us map out the different ages on the surface of the moon. So we use many different tools and many different techniques to measure age on the surface of the moon. Great question. Thank you.
Thanks so much, Brian. We have a lot of
Thank you.
questions here at Universum, but we have two that we are going to join in one. The
Okay.
first one is, what happens to the rockets when they go out to the Earth? What happened to them? Like, they disappeared, like in pieces, they divide in slides, or what happened to the rockets? And the second one is, what happened to the trash that is in the space? Left.
Excellent, excellent question. And this is a big problem for us today, because as we launch more and more things into space, we have, you send a spacecraft to the moon, but you have many stages to the rocket that sent it there. And those oftentimes remain in orbit around the Earth. So if you go out in a dark sky at night and you look up, in the dark sky, you can see satellites. They look like stars moving across the sky. And some of those are active satellites that measure the weather here on Earth, the temperature of our oceans, that help us get television into our homes. But most of the things you see up there are not active satellites. They are trash. They are pieces of rockets, they are stages of rockets that are orbiting the Earth. And eventually, the drag with the outermost fringes of the Earth's atmosphere slows them down, and they fall back to Earth. And as they fall back to Earth, they burn up. It looks like a brilliant meteor in the sky. Just a few days ago, a Chinese rocket burned up over the United States. It was a very spectacular view. Many people saw it. There was great videos of it. But space around the Earth is getting crowded with all of this debris, with all of this garbage. And so this has become a problem that people are working on. And I actually have a friend in Mexico. She lives in Monterrey. And she is very interested in this, and she is studying this. What do we do to clean up space around us? Because you would hate to build a very expensive satellite, send it out into space, and then have it be destroyed by garbage that is orbiting up there. So that is a problem that we are working on right now. It's an excellent question to a very important problem.
Gracias, thank you, Brian. Quiero verificar si Colegio Carol Bohr está enlazado. No lo vimos en las pruebas.
Gracias, Pedro. Entramos un poquito tarde, pero alcanzamos el inicio de la conferencia. Sí, tenemos preguntas.
Adelante.
Adelante, chico.
Aquí es el micrófono. Hello, Mr. Brian. I have two questions, and well, the first one is that I would like to know what is the origin of the moonquakes, and the second one is what's more useful, sending people or using programs?
Okay. So the first question is, what is the origin of the moon's phase or face?
The moonquakes.
Oh, moonquakes, the moonquakes. Very good question. So, when we first started studying moonquakes, we realized that there could be several different types of moonquakes. We realized that there could be moonquakes from meteoroids, pieces of rock in space, slamming into the surface of the moon. And yes, we do see those. We also realized that there could be very deep moonquakes caused by the gravity of the Earth stretching the moon, pulling the moon. And yes, we do see those types of moonquakes. We also realized that there could be moonquakes that are caused by the rock on the moon expanding and contracting as it goes from the very hot daytime side of the moon to the very cold nighttime side of the moon. And yes, we do see those types of moonquakes. So those are three types of moonquakes that we would expect to see and that we do see. But then there's this fourth type of moonquake. It occurs about 25 kilometers deep, and these are the ones that get up to magnitude 5.5 and last for 10 minutes or more. And we do not understand those. We do not know what causes those yet. So that is an area for future study. Now, in terms of your second question, what is better as we explore, to send robots or to send people? And my answer is both. We need both. The Apollo astronauts were able to bring back information from the moon that would have been very, very difficult to do just with robots. But before the astronauts went to the moon, we had to do robot missions to understand the surface of the moon, to prepare the astronauts to do the research that they were going to do there. So as we spread out throughout the solar system, this will not be a question of robots or human beings. It will be robots working with human beings. We need both. We need astronauts and we need robots.
Gracias, Colegio Carol Bohr. ¿Alguna última pregunta o comentario?
Yes. Does the moonquakes affect the Earth's tides?
Do the moonquakes affect the Earth's tides? No, they don't. The moonquakes are just local to the moon itself. And it is not something that we would really be able to measure or notice from here on Earth. In order to study the moonquakes, we had to go to the moon. We had to put scientific instruments on the moon and measure them there. We would never be able to detect those moonquakes from here on Earth.
Gracias, Colegio Carol Bohr. Vamos a una última ronda de preguntas muy breve. Brian tiene una cita en unos momentos, entonces voy a empezar con preparatoria 4. Si por favor activan su micrófono y me dicen si hay alguna última pregunta o comentario.
Morning. My question is, why the rockets launch just before sunset?
So the rocket launches are not always at the same time. So, for instance, when L-Cross launched, it was during the daytime. I will actually tell a story. That was my first moon mission, and I got to have my mother come out to Cape Canaveral there in Florida, and she got to sit there in a special seat and watch the launch. But that was during the daytime. Laddie launched at nighttime. I also worked the launch of Grail that studies the inside of the moon. That was a daytime launch. And so they can launch at different times, but they always have to launch at a specific time. Now that seems funny, but think of it this way. The moon is a moving target. And imagine you have a bow and arrow and you're going to shoot a target. If that target is steady, you can just pretty much shoot at any time. But if your target is moving, you have to shoot at a specific time. So when we launch, we have a very narrow launch window. We know that we have to launch this rocket within just a few minutes. But that time of day that we launch depends on when we are doing our launch and when we are planning to get to the moon. And that changes from one launch to another. Does that answer your question?
Gracias, Brian. Yes, voy a una última pregunta. Tal vez en la sede de Canadá, tal vez ya se animaron a preguntar. Quiero verificar si nuestra escuela de extensión tiene alguna pregunta o comentario.
Yes, thanks everybody. Thanks Brian, and thanks UNAM for the opportunity. I have a question. Did you say that we can help for the, in the research of the moon? How can we do it?
Yes, so there are two wonderful programs that you can participate in. It is called Moon Zoo and Moon Mappers. And let me find that here. So if you do a search on, here, this is one place you can go right here, moonzoo.org. So go to www.moonzoo.org, and you and your students can get these images from LRO sent to your computers there, and you can help us study the surface of the moon. So go to www.moonzoo.org. Okay?
Thank you.
All right.
Gracias, Canadá. Voy a pasar a preparatoria 9, verificar si en prepa 9 hay una última pregunta o comentario.
Sí, muchas gracias. Brian, what would you tell us about the dark space of the moon? I mean, according to different articles that I found in internet, little buildings and kind of city is supposed to be in the on this side of the moon. I think it's false, but what about you?
Well, it's a good question. Where would we want to go if we went to the moon? If we wanted to start living and working on the moon? And it turns out that it looks like the best places to go are near the poles. Because in these dark places on the moon, these craters that are near the poles of the moon, that's where you have the resources that you would need to live. That water, there are millions, if not billions, of tons of water. And that water is very important because course, you will need water to drink, but you can break it up into oxygen and hydrogen. The oxygen you can use to breathe, the hydrogen you can use as fuel. So water ice is extremely valuable. But there's another consideration. On the surface of the moon, across most of the areas of the moon, you have 2 Earth weeks of daylight followed by 2 Earth weeks of night. And that 2 Earth weeks of night can be a big problem in terms of energy. You know, during the 2 Earth weeks of daytime, you can get your energy from the sun, but when it's dark for 2 Earth weeks long, that can be a problem. But at the poles of the moon, just as there are areas that are constantly dark, there are mountain peaks at the poles of the moon that stick up that get almost constant sunlight. So imagine that. Near the poles of the moon, you have areas where you have the resources that you need to live and an almost constant supply of energy. So if you were going to build a building on the moon, a place to live and work, I would suggest to you that I would look at the poles of the moon as being one of the best places to do this.
Thank you, Brian. Voy a pasar a Colegio Ciudad de México para una última pregunta o comentario.
Yes.
Hi, Brian. I'd like to ask if there are any plans about the extraction of minerals on the moon.
A very good question. Are there plans to extract minerals from the moon? And yes, there are. There are companies right now, private companies, that are planning to do this. One of the things that is, of course, of great interest is that ice that we were talking about. And there's a company that I know of that is formed and is putting together a business plan to actually harvest that ice on the moon and then to use that to create rocket fuel that could be used to refuel communications satellites in orbit around the Earth. So imagine you're, one of these communication companies here on Earth that puts up the very expensive satellite TV satellites. But eventually they run out of fuel, and you have to build a whole new spacecraft and send it up again. The spacecraft are expensive, the launches are expensive. But this company has an idea that they will create fuel from the moon and use that fuel to refuel your satellite up there in orbit. And so they will charge you to do that, but that is much cheaper for the communications company than building a whole new satellite and launching it. So that's one interesting idea. Another interesting thing that we're looking at are certain valuable elements on the moon. Specifically, there's something called rare earth elements. And rare earth elements can be very, very important for our electronics, making electronics here on Earth. But just as their name implies, they are rare here on Earth. But we see areas on the moon where there are relatively high concentrations of these rare earth elements. And so again, there are people and there are companies that are interested in going to the moon and harvesting and mining the moon for these resources that could be valuable for us both in space and here on Earth. An excellent question. Thank you.
Gracias, Colegio Ciudad de México. Voy a pasar al Colegio de Ciencias y Humanidades Oriente para verificar si hay alguna última pregunta o comentario.
Bueno, mi pregunta es que si estos terremotos que suceden, ¿puede colapsar con esto la Luna y en qué afectaría a la Tierra?
Okay. Her question is if the earthquakes, the moonquakes that you're talking about, they were to collide, how would it affect, I guess, us, for example? Or would it ever collide?
If the earthquakes collide, so if you have like multiple earthquakes at one time, is that the question?
Yes, if is there any problem with the moon, with these moonquakes?
So moonquakes on the moon are much less frequent than earthquakes here on Earth. So it is not a big problem, but it is a problem that we have to be aware of. And so as we build structures on the moon, we would want to keep in mind that we would need to make them able to withstand a magnitude 5.5 quake that could last for over 10 minutes. Those don't happen really often, but they happen often enough that we've been able to measure them and to see them. But again, because of the fact that we've learned how to survive those types of earthquakes here on Earth, you are very familiar with that there in Mexico. The last time I was in Mexico City, in Ciudad de Mexico, we had an earthquake, and a number of us woke up there in the early morning from the earthquake. But we have learned to live with them here on Earth, and we can learn to live with them on the moon too.
They are asking, here in Universum are asking about where do you live? You live in an earthquake place too.
Yes, so I live in California, near San Francisco. And here we have a very famous earthquake fault called the San Andreas. And we have had some big earthquakes here. Biggest one that I have gone through is magnitude 6.9. And that caused buildings to fall down, cracks to open in the earth, a bridge to fall. It was very, very spectacular. So, yes, we have earthquakes here just like you have them in Mexico.
Bien, thank you, Brian. Voy a regresar a Colegio Carol Bord para una última participación.
Gracias, Pedro. Adelante.
Thank you. At the beginning of the conference, you showed us a picture of astronauts' footprints in the moon. What distance did the astronauts walk?
What was the last part of the question?
Well, what distance did the astronauts walk?
Oh, what distance? The distance that they walked was actually fairly short on the first few missions. So imagine if you were on a soccer field, there on a football field in Mexico, the distance that they would cover would probably fit within a football field. That was, so Apollos 11, 12, and 14. Starting with Apollo 15, they decided they wanted to go further. And so they actually took a car with them. So when they landed, they were able to unfold and pull out a car, an automobile. And they could get on that car and they could drive now for much further distances. So Apollos 15, 16, and 17, now they were able to explore much further. But there is an interesting story. On Apollo 17, they were driving along. Now imagine that. You are the only car on the entire surface of the world. Only one car. And yet they managed to have an accident. They actually knocked the fender off of their car by hitting a rock. And you know, these astronauts may be the best pilots in the world, but there were many jokes that they may not be the best drivers. But so the initial space exploration of the moon was a very limited area, just right around the lander. Again, something that would fit in the size of a football field. But later on, when we started bringing cars to the moon, we were now able to go much further distances. Very good question.
Thank you, Brian. Finalmente, Colegio de Ciencias y Humanidades Naucalpan, quiero verificar si hay pregunta o comentario en CCH Naucalpan.
Sí, tenemos pregunta.
Gracias, SSH Naucalpan. Y entonces, aquí las últimas... adelante.
Is there kind of radioactivity on the moon?
Is there what?
Any kind of radioactivity?
Oh, radioactivity on the moon. There is, yes, there are big problems with radiation on the moon in terms of you are exposed to radiation from the sun. You know, here on Earth, we have magnetic fields that protect us. We have the atmosphere that protects us. On the surface of the moon, the radiation from the moon in terms of electromagnetic radiation and in terms of particle radiation, you are exposed directly. So that is a problem. In addition, you have the radiation from deeper in space. And another problem is that a lot of this radiation, specifically in the form of neutrons, can hit the ground and can cause scattering of particles, breaking up of atoms on the surface of the moon. And you can see that radiation actually emanating, not just coming from the sky of the moon, but you can have radiation coming off the ground of the moon too, because of that flux of radiation coming in from space, hitting the neutrons, hitting the ground, breaking atoms up, and you get a flow of particles flying back at you from the surface of the moon. So protection of radiation from radiation is a big issue. Now, in terms of radioactivity, yes, there are radioactive elements on the moon, but the biggest radiation that we see is, again, coming from space and then coming back off the moon from the interaction with this radiation from space.
Gracias, Brian. Thank you, Brian. Las últimas preguntas aquí en Universum.
Did once a time lunar atmosphere could be larger or bigger?
So was the moon's atmosphere bigger a long time ago? And yes, probably when the moon first formed, we realized that the moon had an ocean of lava. And so you can imagine a lot of stuff, gases coming off that ocean of lava. So the very early moon, yes, probably did have a bigger, thicker atmosphere than it does today. It would not have been a nice atmosphere. It would not have been the kind of atmosphere that you would want to breathe. But yes, it would have been thicker than the moon's atmosphere that we see now. Excellent question.
Gracias, Brian. La última pregunta, the last question.
Hello, Brian. My question is, why does the volcanoes are under the ground and not like in here in the earth, above the water, the
Wonderful, wonderful question. Why are the volcanoes on the moon different than the volcanoes that we have here on Earth? On there, and about near Ciudad de Mexico, you have Cilatepetl, and you have Ixti, and you have further east, you have you have wonderful tall volcanoes, but we don't see those on the moon. One of the things that happens on the Earth is that you have pieces of the Earth's crust that will collide, and one piece of the Earth's crust dives down beneath. And as that happens, it melts. And so the lava becomes thicker from some of the material, the silica that is in that crust. And so you get this thicker, pastier kind of lava that can erupt, and it builds up a tall volcano. On the moon, the lava was mostly what we call basalt, a very thin, runny kind of lava. As a matter of fact, imagine you take some olive oil, some aceite, and you pour it on a table. The lava on the moon was about as thick as that oil. And that's hard to build a mountain out of, isn't it? And so, because the moon's lava was so thin and so runny, we don't see the really big, tall volcanoes on the moon that we do here on Earth. That is a wonderful, wonderful question. Thank you.
Thank you, Brian. I know you have an appointment right now, so we are going to finish the session. Thank you.
Thank you very much. Thank you, Pedro. Thank you, all of you.
Thank you.
Thank you, Brian, and bye.
Thank you, Pedro. I'll talk to you soon.